Hello everyone, welcome back to the channel, and we are going to continue developing the chess app, which we have been doing so for the last several videos. In today's video, we are going to take a look at how we can move the pieces about. In the last video, we saw we rather created our own input manager to handle all the user input, and in today's video, we are actually going to use that input manager to move the pieces about and animate the pieces moving about on the board. So let's get right into it now. This is where we last left off. Over here, I have a few things I wanted to talk about, which I kind of missed in the last video, and these commented out sections are what I'm going to talk about. First of all, in the input manager class, I think I made a typo and I wrote down get component instead of add component in this line over here. So from next time, I will make sure that we actually test out any new classes we create in the videos so that we don't have any errors like this. Another thing, I think I actually missed to assign this value to the instance variable, and we were supposed to do that in the start function. And don't destroy on load. This just makes sure that if we ever change scenes in our game, then this input manager instance is not destroyed. So that is it, that's all I wanted to cover. So instant equal to this, don't destroy on load game object, and add component instead of get component. So if we're copying down this input manager, please make these changes. And yeah, so now we can finally move on to actually moving the pieces on our screen. So first of all, we need a few new classes. The first class I want to create is going to be called player, and this is going to take care of all the logic pertaining to how we are going to select the pieces, so the game knows which piece we want to move and the square where the piece has to move to. And one more is going to be for a game manager. Yeah, so this class, you can see that whenever a script called game manager is created, Unity automatically gives it this icon instead of the normal C sharp class icon. So a game manager, this is going to take care of all the stuff for basically managing the game. It's going to take care of which player's turn it is, if the game is still in a playing state, or if the game has ended in either a draw, or if the white player has won, or if the black player has won, and all that other good stuff. So the game manager. Now we are going to how are we going to use the game manager? We're actually going to create a new empty game object, and we're going to call it the game manager, and we're going to assign it the script, and that is going to take care of all the managing the game managing stuff for us. Okay, now we can actually start fleshing out the player class first. So we don't need this. We do need using system.collections because we are going to have a thing called events in this class, and that is necessary. We don't need mono behavior. This is going to be a standalone class without inheriting from the Unity mono behavior class. And okay, this is going to take care of how we are going to select the piece and how we are going to move the piece. So the first thing, we have two input states. So the game knows if whenever we click on the chessboard, either we are selecting a piece or we are selecting a square for an already selected piece to move to. So there are two states, selecting piece state and moving the piece state. So we're going to create a public enum and input state, and this is going to have two values, none and select piece. So the none value is when no piece is selected, and the select piece value will be there when a piece is actually selected. Then we need a few references, one to the camera, and we're just going to call it cam. You'll see why we need a reference to the camera in just a little while, so just bear with it for now. Then we need a reference to the square which has been selected. So vector to int selected square. This is a vector to int because it's going to store the file and rank of the square, so we know what square we have selected. And one more, which is for the, if I remember correctly, yeah, and one is for the sorry guys about that. I actually paused the video because I had to take care of something in my actual life. I do have a life. So one is for the current state we are in. So it's going to be an input state, current state. Okay. And now, since this is not a mono behavior, we actually need a constructor for this class. Then this is going to be public player, and we can just initialize all the values inside this constructor. So current state is equal to input state dot none, and I think that is it. We don't need anything else. So now for the update class, which is going to be which is where all of the logic is going to take place, public void update. So now we created the input manager in our last class. Now for first we need to check if we are actually tapping the screen of a device. So how are we going to check that? There's a very quick and easy way to do this. If input manager dot instance dot tap, so this just makes sure if we are actually tapping the screen. Oh yeah, and there's one more thing we have to go over. I have created these two static getters for the tap and the touch position. So since these are private values, we need two public functions for the tap boolean and the touch position, which will return the vector 2. So this is what we are using over here, input manager dot instance dot tap. This checks if the value in the tap variable is either true or false. If it is true, then we are actually tapping the screen. Then we need vector 2, and I'm going to call this a pointer. This is going to be the position we are actually tapping the screen on, and this is going to be equal to input manager dot instance dot touch position. But this is actually in screen space, and we need this to be in world space. So for that, I'm just going to wrap this around parentheses, and we have a reference to the camera. So cam dot screen to world point. So this is a function we need. This just converts the coordinates from the screen space to the world space, because all our squares on a chessboard are in world space. So we have to convert these coordinates to world space. And now that this is taken care of, we check which input state we are in. If current state is equal to input state dot none, then we have to actually select a square, and we'll create a function for that, select square, and we pass in the pointer, that is the position. And else, if we are in the select piece state, input state dot select piece, then we create a function to update the position or update the board on our screen. So update board, and here also we pass in the pointer. So we create a function for this and also for this. So inside the select square function, all we have to do is make sure that the position we're tapping the screen on is within the bounds of the chessboard, and if it is, then we update the selected square variable to whatever square we have tapped on, and that is it. And we also change the input state to input state dot select piece. That is it for the select square function. Now we actually have to figure out a way to do this. So first of all, what I want to do is make sure that we are in input state dot none and update it accordingly. In case it doesn't work out, the select square function doesn't work out, or if something goes wrong, then we are still in the input state dot none state and not the other state. Then we have to create a function to make sure that we are within the bounds of the chessboard, and at the same time we have to update the selected square function. So what I'm going to do is I'm just going to assume that there is a function, and I'm going to name it get selected square, and I'm going to pass in the pointer variable, and I'm going to pass in a reference to selected square. What this out keyword does is this is like a pointer. This passes in the selected square variable as a pointer, the address of this variable, so we can update it from somewhere else in a different C# class or a different function. It doesn't actually pass in just this variable as a parameter. It actually passes in this variable, not just a copy of this variable. So that is the get selected square function. And if the selected square is within the chessboard, that is if it returns a true value, then all we have to do is current state equal to input state dot select piece. That is it for the select square function. Now we actually have to uh, flesh out this function. This function I'm actually going to create in the board UI class, because um, it will have some dependencies on variables in this class. Public static get selected square, and this is going to take in a vector2 position or pointer to keep it consistent, and out square index vector2 int square index. This is a vector2 int, right? Let me just make sure. Yeah, this is a vector2 int. Okay, so first of all we have to assign a value to the square index variable that we are passing, so that it does get updated. And why is it giving me an error? Okay, public static boolean. Yeah, this is going to be a boolean. So square index is equal to vector2 int dot round to int, because this is a vector2 and we want to convert it into a vector2 int. So we are going to round to int, and inside this what we are going to do is take the pointer variable, subtract it by vector2 dot 1 times half the square size by 2, and let me just get back. Okay guys, I'm back, and yeah, so we're going to subtract half the square size, then we're going to add the bounds of the chessboard, and we make sure that we convert the bounds to a vector2 because it is actually a vector 3, and then we divide it by the square size, and that is it. I think that is how we are going to convert the position from the pointer to the square index, that is the square we have actually tapped on, and then we get a reference to the file, which is just square index dot x, and the rank, which is just square index dot y, and then we make sure that these files and ranks are within the bounds of the chessboard. So we can just check them like this: file is greater than equal to 0, and rank greater than equal to 0, and file is less than square count, and rank is less than square count. So that is it for the get selected square function. So let me just walk you through this function once again, and bear in mind this video might be a little bit longer than the previous few videos, but it is going to have a lot of concepts, and it is an essentially important video in this series. So first of all, we're updating the value of the selected square. Let me just yeah, selected square. We have called this square index over here just for namesake. So what we're doing is we have the position in world space. Of the position we have tapped the touch screen on, or where we have pressed the mouse button on. Then we're subtracting half the square size from that position. We're adding the bounds, and then we're dividing it by the square size. And this formula will give you the index of the square which you have tapped on. Now, very easily we can get the file and rank of the square, and just make sure that these files and ranks are within the bounds of the chessboard, that is, they're greater than 0 and less than 8. And we have the get selected square function. Now we can go back, we can get rid of this, and instead of this we can use static board UI, because that is where we have defined the function, and this automatically works. Now we move on to the update board function. This function is going to have a vector2 int, which is going to be the target index of the square, or rather the target square. The target square, we make sure that the target square is also within the bounds of the chessboard. So again we use get selected square pointer and out target square. If it is within the bounds of the chessboard, we have to make sure that it is different from the selected square, which has already been declared here and occupied by this function over here. So if it is the same, if target square is the same as selected square, then we don't do anything, we just return, because over here we have already set the current state to input state.none. So whenever we click on the screen next time, this function will automatically get called. And if it is different than this selected square, then we actually have to invoke the event. So we haven't actually declared the event here. So what I'm going to do is public event action, and this event is going to be of a type vector2 int array, and I'm going to call it move executed. So this is an array of vector2 int because it's going to store in two vector2 ints, one for the start position of the square and one for the final target position of the square. That is essentially the move we are making in the game of chess, the start square to the end square, or rather the target square, and that is why it's called move executed. So that is the event. So we actually have to invoke this event, move executed dot invoke, and we pass in a vector2 int array. So let me just create this vector2 int array here first, and I'm going to call it as move. So move will be equal to, first of all, the selected square and the target square. This is the move vector2 int array, and I'm going to pass it in, and then we just make sure that current state is again equal to input state.none to prevent any errors. So what error are we still getting? Okay, that's very easily manageable. So what we're doing is we are creating a variable called move. The move is basically just storing two values, one for where we begin to move the piece, and the second, the target square, where we actually want to move the piece to. So that is it for the update board function. Now we have created this player control class, and it has all the logic for the touching the board, getting the target position, getting the start position. But how are we actually going to use it? Okay, so first of all, we are going to use it from the game manager class. So if we go back to open this up, we can get rid of all these. It is going to inherit from mono behavior, so we can keep this. So what does the game manager class need? Well, first of all, it needs a reference to the player which we have created. So private player, that's the player. Next, it needs a reference to the board UI class, because that is where all the board updating is going to happen. So private board UI, Okay, and now we actually have to initialize these values, and we can do it in the start function. Player is equal to new player, and board UI is actually attached, is a script attached to a game object already in the Unity editor. So we can do game object dot find object of type, and we pass in board UI as the type. This will automatically find the board object class for us. And in the update function, we have to update the player, because in the player's update function is where all the logic is happening for the move making of the game. So player dot update, and now we actually need a function which subscribes to this event over here. And what I mean by that is, whenever this event is called in the update board function, we need a function which actually makes the specific change in the board UI class and is subscribed to that event. So we can do that over here. Player dot move executed plus equals, and let me just call this function also move executed, just for consistency sake, and that is it. Let me generate a method for this function, and I'm going to call this as move. Okay, so inside the move executed function, uh, what we need is for board UI to have a function which uh, which can be called from here, board UI, and let's just call this function as move executed as well. So move executed, and we'll pass in this parameter over here. So let's just generate a method for this in the board UI class. And where is it? Okay, so this isn't actually a static function, so let me remove it from this region, and we'll move it to this region of public functions. And yep, okay, this should work. Now in the board UI class, we need two things. One, we have to actually update the position in the sprite renderer array sprites, and two, we actually have to animate the move so that it doesn't look messy. We can actually tween the piece moving from the start square to the target square. So we need two functions, and these are both going to be private functions. First, we have to update the position, and second, we need a private I enumerator, and this is going to be animate move. Okay, what is an I enumerator? An I enumerator is something which allows us to iterate through our iterable, which can be, we can iterate through frames, or we can iterate through an array or anything like that. Mainly it's used for delaying actions. So for example, if you're playing an RPG game and you have a boss standing on a cliff and he has to jump, we have to make the jump animation, he'll take out his weapons, and then the battle with the player starts. And then if you have to do something in sequence and you have to delay or wait for a few seconds, that's when you use an I enumerator, which uses the yield return statement to actually skip over frames or wait for a few seconds for the, okay, but that's besides the point. This is going to be a private void, and yeah, private I enumerator. And for the public function, we have move executed, which is going to start coroutine, which is going to have animate move inside of it, and it's going to take in the move variable as parameter, and also it's going to have the update position, which is also going to take the move variable as the parameter. So let's just add this in vector2 int array move, vector2 int array move. So now we can actually start fleshing these two functions out. First of all, we take a look at the update function. The update function, it's quite simple, just a few simple lines of code. First of all, we take a reference to the start square and the end square. So vector2 int start square move. This is the first index in the move variable. Vector2 int target square. Oops, pardon me. Target square, and this is going to be okay. Now we need a reference to the target piece. So this is going to be a sprite renderer, and we're just going to call it target, and this is going to equal sprites of target square dot x and target square dot y. So now we have a reference to the piece which is on the target square if a piece exists on the target square. So if a piece exists on the target square is not equal to null, oops, then we actually want to destroy the piece because it's going to be replaced by whatever piece is present on the start square. So destroy target, and then we can start with the replacement of the pieces. So sprites of target square dot x and target square dot y is equal to sprites of start square dot x and start square dot y, and sprites of start square dot x start square dot y is equal to null. So what we're doing here is we are getting a reference to the start square and the target square. Then we are getting a reference to the piece if it exists on the target square. If it does exist, then we destroy that piece immediately because it is going to be replaced by the piece which we are going to make a move with. So basically we are simulating the capture attack. We're attacking a piece on the target square by the piece on the start square. Then we set the the start square equal to null because the piece has moved from the start square and now it is at the target square. So that is it for the update position function. Next, we take a look at the animate move function. So the animate move function is it's going to take a few values. So first of all, we need a float t which is equal to 0. Then we need a float for the duration of the animation. Let's say it's going to last for 0.15 seconds. Then we need a reference to the start square and the target square again, and we can easily just copy these two lines of code over from the update position function. Then we need a function, then we need a reference to the actual positions of the start square and the target square, not just the indices of the squares. We need actual coordinates, which we can do so from the get square center function, which we declared all the way back in the first video. So vector2 start position, which is going to be equal to get square center start square dot x start square dot y, vector2 target position, which is going to be equal to get square center target square dot x and target square dot y. Then we need a reference to the transform component of the piece we are moving. So that can be transform piece transform, and that is going to be equal to sprites of start square dot x start square dot y, and we access the transform property of the sprite. And while we start the animation process now, while t is less than equal to 1, we okay, so while t is less than equal to 1, we have to yield return null. So we are doing this because an enumerator function expects a yield returns statement. What the null value does is just tells the function to skip over one frame, and that is essentially what the yield return null statement is doing. Then t plus equals t plus equals I forgot what it was supposed to do actually, so let me just get back. Okay guys, I'm back and sorry for the delay. So this is going to be time dot delta time. So time dot delta time is essentially the time passed between the last frame and the current frame. So it is basically the time in between any two consecutive frames, and we are going to times that by 1 divided by the duration. And this can also be a constant actually, because it's not going to get changed. And then what we're going to do is piece transform is equal to vector2 dot lerp. So start position, target position, and t. Piece transform dot position. And yeah, so vector2 dot lerp basically just interpolates between two given values a and b, and given by the t variable. So this will animate the whole process for us. And if we go back to game manager now, there are no more errors. And yeah, so if we try and run this code now, it should work without giving us any errors. And this was a lot of information to take in, but if you rewatch the video a couple of times, then you will get the hang of this. And okay, we don't have errors, so that's a good sign. So if player.27 object reference not set to an instance of an object, game manager 24 player 27. So let's try to debug this. Game manager 24, okay, and player at 27. Vector2 object reference, okay. So cam, we just didn't initialize this. Cam is equal to camera dot main, and that should get rid of the errors for us. Now if we try and run the code, we shouldn't get any more errors whatsoever, hopefully, fingers crossed. So okay, it is working. What about if we try to attack the enemy piece? It is working. Okay, so as you can see, it is working, but there is no check on whether a move is legal or not. So right now there's nothing stopping me from attacking my own king or my queen going directly to the enemy king. So that we're going to take a look at in the next few videos, how we can check the legality of moves, prevent checks, and all that other good stuff available in chess. That is going to be it for this video guys. I'll see you guys in the next one. Peace.